Hello students. So in this lecture we will learn about fully associative mapping. So in that case what happened actually, there is no any kind of formula and there is no any fixed things that in line 0 only this type of the blocks are possible and others are not possible. So because this was the great harm in the direct mapping, and this was a problem in the direct mapping, that if the line 0 is empty and no of such data is required over there, no particular block is filled there over there, then this will be totally empty and it is a loss, basically a loss for the of the space. Fine. So to tackle this problem, fully associative mapping is considered, and in that case also I am just taking the same example of 31 blocks. Same number of the blocks are there, same number of the words are there, and in that case what we have tagline. We have tagline of 5-bit, and because 5 by 5-bit, because all the blocks are possible in any of the line. So if L0 may have a B0, B1, so on. L1 can have any of the block. L2 may have any of the block. L3 may have any of the block, right? So because any of the block is possible in any of the lines, so that's why I am providing 5 bits over here, so that the number of the block can be defined, and which word is needed, because block size is the same as line size. So number of words in the line are equal to number of words in the block. So these are also 4, these are also 4, so no any kind of description over there. So here we can say that any of the line is possible in line 0, any of the block can be stored in a cache memory of line 0, any of the block can be stored in line 1, any of the block can be stored in line 2. So it provides me flexibility to store any kind of the block at any space of the line of the cache memory. Okay, so same thing here also, we have line size equal to the block size, means number of the words in the line are equal to the number of the blocks number of the words in a block. For main memory, 5 bits are for the block and 2 bits are for the offset, and in the cache memory 5 bits are for tag line, tag number, and 2 bits are for my block offset. So that's how we work in a fully associative mapping. Now you see here there is 0001010 is the CPU generated address, and 00010 is my tag number, and 10 is my block offset, right? So no line number is generated address of the CPU, only tag numbers is there. So tag is 00010 and 10 is my line is my word number, right? So if for example if CPU generated this one, right? So if CPU generated, for example CPU is generating this one, it is more easier example, and if it is generating this address, so that means 8th word is needed here, and in that 8th word what we have to do, we have to put in line 0. So what is it showing, where it will be happen, it will be 8th word, right? It will be 8th word, and where it may be stored, 8th word can be stored in that case. For example, if it is 0010 if it is 0010, so my tag line is 0010, so 0010 can be accessed from that case. So so my tag number is defined in the memory management unit. So I can define it that there is a 0010, so which block is possible here, and after that 0010 means it is block number 2, so any of the word from this is possible in that line number. Okay, any of the word from W8, W9, W10, W11, any of the block is possible to be stored in this cache line. Okay, so this is defined in the memory memory management unit, and memory management unit knows that this line number, it has been provided by the this tag line. Okay, so by means of the lookup table, it will find that which tag line, which tag number is associated with which word. Okay, for example, here in this example you can see that this is 00010. So if it is assigned to line 0, if it is assigned to line 0, means now in that case line 0 will contain W8, W9, W10 and W11. So which word means 10. 10 means second word. So second word means it will assess W10. So this word will be assessed by the CPU, right? Similarly, if it is 00010, 00, so if this is this is the thing, so means 8th word is needed in that case, and it is assessed from line 0. Okay, so that's how it works basically. So it is all about the fully associative mapping. In my next lecture, I will discuss with you about set associative mapping. Thank you.